Just giving it one more minute. All right, guess we're all set. Hello, welcome to the Apache, I guess, what do we call it these days? Apache OpenWhisk Project Tech Interchange meeting. I haven't hosted for a while, so excuse my illiteracy there. Going through the usual agenda, do we have anybody new on the call who hasn't been on the call before? Okay, if nobody speaks up, I guess we're all well known. Matt, it says I shall request record permission. Oh, maybe I misclicked, sorry. I think I misclicked. Yeah, then next points on the agenda are generally, did anything notable happen in terms of code contributions over the last 2 weeks? Anybody want to share an update? Dave, maybe on Cube?
Yeah, just I guess quickly on Cube, probably the main change is that we upgraded to Cube 1.9 as the minimum level for support for the Helm charts, and we're doing testing against Cube 1.9 and 1.10 now. There have been some small cleanups and contributions to the Helm charts. Daisy's done some work on the provider charts. It's been nice. Not too much else, I don't think.
All right, thanks. I think to the main repository, if I scroll through the commits, one notable change is from Tyson, which is containers will now not be thrown away if there's just an application error in the action, but they will be kept around. So only system errors, or I guess we call them developer. No, we call them. Do we call them container errors or developer errors now?
Now they're developer errors.
All right, so only developer errors and system errors are counted to be actually deleting containers and restarting them. And the second notable one is that the container reuse strategy changed as well. We discussed this on the dev list, and Tyson thankfully implemented to actually close and throw away the whole HTTP client, or rather the connection pool on container pause, and then recreate it on unpause, which solves a couple of nitty-gritty issues because container connection pools don't fare very well with pausing a container and unpausing it, because that behavior is kind of weird there. So yeah, that's what I can see in terms of notable changes to the main repository. Anybody else want to speak up on notable stuff? I guess not. Yeah, then I guess we can move on to the agenda, which only has you, Tyson.
All right.
So stage is yours.
Okay, so basically I wanted to give an update on, let me share my screen here. Concurrency PR, can you guys see this? Anybody? Is my screen sharing okay?
Yep, it's fine.
Okay. So a couple of reasons for this. One is that there's some additional changes that I've been working on for this concurrency PR, and then the other is I need some help reviewing this, and I will point out a couple of particular areas to pick on. We can either talk in this meeting or in the PR, whatever people are comfortable with. So the basics pull request is 2795. I just added some details to this presentation that I gave at a meeting previous, I think maybe in June or maybe earlier. So I merged a couple of PRs into this single PR, specifically to previously did not include per action limits on concurrency. So that's in there now. And basically this is implemented as another piece of the action limits class inside of OpenWhisk. So in addition to log collection caps and memory requirements and timeouts, there is now also a concurrency limit where when you create an action, you can specify a concurrency limit. And the defaults would be to, the concurrency limit would be 1, and the default maximum would also be 1. So operators would have to enable this explicitly to allow developers to use it. And then before going into more details, just one other heads up is that, in case it's not cleared, these changes are strictly for the OpenWhisk core repo and the OpenWhisk API. So in order to enable action developers to use these with the CLI has to be extended to also support these changes to the action limits schema. Once this is completed, then the next change would be to the CLI, just to be able to leverage the concurrency action limit from within the CLI. Just some notes on adding support in the Node.js runtime. This was done a little while ago. I didn't put a link to the PR here, but basically, I added some tests and some, basically it uses the new akka client in the main repo to enable the HTTP client to behave properly with concurrent requests. The Apache client does not behave properly. There's tests there if you want to check those out inside the Node.js runtime repo. So one item that people should know about is that the log collection is kind of, it doesn't work out of the box. And so anybody who wants to, as an operator, enable concurrency support in their OpenWhisk deployment would have to have a runtime that supports log collection in a way that will work with concurrent activations. And so what that means is that you need to have a custom runtime to produce the log structure because you will inevitably end up with logs that are interleaved. And so here's an example where, in our case, what we've done is we've overlaid a log structure that includes the activation ID. We include a timestamp as well. And then the original log message that comes from somebody typing, somebody having console.log in their action code. And so we have to coordinate, this activation ID 2 has to come from the activation ID whose activation is 2. And so in order to do this coordination, I think it's not clear if there's like a great solution that everybody will like. And so for now, I'm suggesting that the runtime has to be customized by an operator to do this. I don't know if people have opinions on that, but I think in order to kind of progress on this, we need to have the support in the core repo. If there's a good way that people agree on to do it in the runtimes, we can do that. But I don't think we need to do those necessarily at the same time. It's just that people need to be aware of the configuration requirements of, the kind of the ramifications of enabling the concurrency support at their OpenWhisk cluster. So changes that were made to controller and invoker recently. So there was, with the recent, I guess it's not that recent anymore, but the changes to the load balancer to deal with memory slots, so that it would pay attention to memory allocations per invoker. That was merged from upstream into this PR recently, and I refactored the work that was in the original PR to also add in another kind of slot scheduling piece, so that in addition to paying attention to memory slots and in the invokers, there's attention paid to concurrency support for actions at the load balancer layer. So the good piece of that is that there's nothing special that needs to be done in the controller configuration to add support for concurrency. The bad part of that is that the scheduling gets a little bit more complicated, and one of the particular areas that I'd like some eyes on for review is when containers start, in addition to allocating memory slots, we have to synchronize allocations around concurrency slots in order to get accurate numbers there. And so if I'll point out in some PR comments exactly where that happens. I've asked a couple of people already to look at it. If anybody has time and interest in looking at that, let me know. I'd love to have opinions on it. The invoker, there's the notable configuration change there is that there's a concurrent peak factor to allow increased message peaking, so that if there's actions that are supporting concurrency, then additional messages will be pulled off of Kafka, rather than pulling one message per container. If there's potential for having multiple messages per container, then additional messages will be buffered into memory. I kind of talked about that a little bit in previous meetings, so I won't go into great detail there, but that's the configuration change that needs to be enabled at the invoker to support this. So the two controversial pieces that I've kind of mentioned, one is the synchronized piece of the scheduling in the controller, and the other one that some people have commented on in the PR already is advertising runtime support of concurrency. And some people ask for adding a field to the runtimes manifest to indicate concurrency support, so that when you create an action, if you indicate that it's using concurrency greater than 1, that it would fail immediately. And the concern I have with that is it's not clear how we would do that for black box containers. If we want to enable black box containers to support concurrency, they won't have an entry in the manifest, and it's, I'm just not sure, what the implication there is. So one of the ideas that I've tossed around a bit is enhancing the init protocol to allow a image to indicate back to OpenWhisk what types of actions it supports. And so things like concurrency limits, or if there's specialized resources that the image is capable of using. This has another set of problems, which is, it will only be processed when the action is actually invoked. as opposed to when the action is created. So there's a life cycle difference there, but it's certainly a bit more flexible so that black box is supported, and it may be possible to do other things by providing data during the init workflow. And the option 3 here is what for now. What I would like to do is nothing, so that it would have to be a conscious effort from an operator to say, if you're going to enable concurrency at the OpenWhisk API layer, the implication right now is that all of the runtimes that you have in your manifest also support concurrency. I don't know how realistic that is for any operators, but I think it's an incremental step, and that this can be added later if there needs to be some specific support for coordinating these between the runtimes that may or may not support it, and the OpenWhisk API deployment that may or may not support it. So, thinking about these two specific areas: one, the load balancer change, and two, the coordinating runtime support between runtimes and the OpenWhisk layer. Does anybody have any comments or feedback on that?
Yep, I do. Let's start with that runtime support. I agree. Doing nothing for now is fine. It's anybody can decide for himself if he wants to enable that or not. Even further, it might even be fine to not do anything at all and just make those runtimes that need to be single concurrent. I mean, from a technical point of view, it's more likely that all of your runtimes do have concurrent support versus really needing single concurrent support if we resolve that logging thingy. So it might make sense to just shut down those who have single concurrency and just shut their run/run route down to say, hey, you called me concurrently, you're not allowed to do that, I'm failing now. So that might be an indication as well, although it fails even later than on init, so there might be some consideration needed there. But I agree, for now it's fine to leave it as is and and deal with the changes that we have at hand for now. For the synchronized support, from my understanding, what you're essentially doing is you have a map tracking the containers in a certain invoker, and then you need to track how many requests you send down there. Plus, you need to track the memory allocation down to the invoker. Is that correct?
Yes.
So I guess my question will be, can we break that out into a separate PR? Because tracking the containers in the load balancers is in itself a pretty largish change, in my mind at least.
So I guess I don't really know how that would be able to be broken up, because the problem is that we definitely only want to do that tracking when concurrency is enabled, right? And like,
well, how consistent is the tracking? Like, how I have only looked briefly through it, but as we don't have any other items on the agenda, we might as well discuss that bit here.
Yeah, sure. And if anybody has other items they want to bring up, please don't let this monopolize things. But so right now it's strictly consistent. So I created a test that. Let me back up a second. One change that I didn't really mention that people will notice in the PR is that I did refactor the sharding load balancer. I forget the name of it exactly. I did refactor the load balancer so that we can test the actual end-to-end workflow of publish to completing a message or completing an activation. And so what I did was add a test there to kind of semi-concurrently, as much as possible, saturate the publish to complete workflow with different sizes of batches of requests so that we can test scenarios like you have no containers in the system. And then the next one is you have one container in the system and it has concurrent slots available. And then you have one container in the system and you have no concurrent slots available. So the next one is going to have to create a new container and allocate both memory slots and concurrent slots. Anyway, so I created a test that goes through different batch sizes up to the complete saturation of the whole system to kind of verify that all these cases have kind of predictable behavior with respect to allocating memory slots and allocating concurrency slots. So all that to say, the tracking is accurate as far as I can prove at the moment, and I think it's doing a good job there. But it is reliant on synchronizing when there's a allocation of memory slots as well as an allocation of concurrency slots, since those kind of need to be done in lockstep.
So what you're doing is you send I haven't read the code thoroughly, but if you invoke an action on an invoker, you look up into a map if on that invoker you already have a container for that action, and if not, you create one. Like in that map, you say create a container quote unquote with a semaphore of X concurrent requests available.
Yes.
And before you do that, you ask for slots of the memory that you need for that container.
Yes.
Okay. And when you reach the concurrency limit, what do you do then? Do you assume that if there's 3 slots, you can just top up those concurrent slots?
Yes.
So that's why you need a resizable semaphore there.
Yes. Yeah.
Okay.
So once the concurrent slots are used up, and a new container is created, then in the synchronized piece, I was going to do a workflow diagram and I haven't done it, so I'll describe it to you. In the synchronized piece, we recheck the concurrent slots, and if there's still not enough, then the memory slots are allocated or attempted to be allocated. So there is a double check there. Because
got it. Yeah, I'm trying to lead to a point. And how is container deletion handled? Like when the invoker decides to kill a container for whatever reason, how's that? Are both algorithms synced up in a way, or how does that work?
So it only works on the completion, and so I think that's how the memory slots are also freed in the current scheme. So that's kind of what I followed, and the way that the memory slots are deallocated in the context of concurrency is that once the concurrency slots are kind of released to a value that's a factor of the max concurrency for that action, then we know that a container will be deallocated by the invoker, and so the load balancer also deallocates the memory slot in that case. There's no actual coordination between the controller and the invoker, just like there's not today, really. And so, this is all kind of assuming that the completion process is reliably called for every activation. But I think that's also implied by the slot handling of today.
Okay, so if you, for a simple example, if the concurrent number falls to 0, you just say, okay, from now on, I cannot tell if the invoker deletes or keeps stuff around. So I'm assuming that I don't know anything and I just throw the state away.
Yeah.
So from the load balancer's point of view, if you ever dropped down to 0 and you start again, from the load balancer's point of view, you create a new container.
Yes.
Okay, gotcha. That makes sense, and that also puts a little nail into why I wanted to split this up into a separate pull request. My thinking was, okay, if we start to need container tracking, like if we wanted to do this for a long time, like pull container state up into the load balancer and stuff like that.
Yeah.
I was going to suggest, shall we do that then, and then implement concurrent requests into that model? But what you described is actually simpler in that you don't need to worry about actually really tracking what the state of the invoker is, because you have that fallback mechanism of saying, if concurrency falls down to some well-known value, I can just throw the state away. So that's simpler than really tracking what's going on.
Yeah. Yeah, it's definitely simpler. It does, make assumptions about, the invoker's actual behavior, but no more than the existing kind of memory allocation behavior does.
Yep. And the synchronous.
I'd be worried about trying to push more detailed tracking of container state up into the load balancer, or I think architecturally maybe heading away from that, right? We sort of look at some of the discussions we've had over the last month of trying to switch to a more scalable system.
Yeah, I think I think there's different aspects to it. So there's I think the exact precise state of the invokers can't or won't be possible to be tracked at the controller level. But what's more interesting to do, I think, as far as like adding more coordination, is tracking different types of resources. And so things where you have a heterogeneous pool of invokers, for example. So an invoker isn't part of a static configuration where all invokers have 24 gigs of memory, but I have spot instances, and these have 8, 12, 16 gigs of memory, or some have GPUs, some don't have GPUs, things like that. Those types of things that would contribute to the health state details of the invoker, I think would be good to add to the information that's sent back to the controller. But the actual state of warm containers and concurrent state of use of each container are too fine-grained to be able to track reliably.
Right. I guess I have my Kubernetes blinders on, and in that world, even keeping track of the memory that's associated with an invoker is sort of not the right model, because the invoker doesn't have memory, really. Right? It's just managing a bunch of containers that are scattered across the cluster.
Yeah, right. And I'm ignoring that for the moment, but yeah, I think that's exactly true. Is that like an invoker having memory is a bad metaphor. It's more like the invoker has the capability to support a container with this that has these memory needs.
Right.
Is a little more accurate.
I think what you're proposing makes sense, and it fits into the model that we have been discussing on the dev list, in that really we should only be tracking that concurrent number. And in the architecture that we discussed on the dev list, that semaphore that you need to get for memory is done by a whole different component with its own state model and stuff like that. So I guess from that point of view, it's fine. And I agree, we cannot break it up sensibly in a separate pull request. So if Dave, do you have more questions?
No, not on this particular thing. I was just going to say, back to the runtime support, I sort of like his option 2 as a broader thing in general. It'd be nice if a container can return basically a dictionary of the capabilities it's capable of doing to give us more flexibility. But I don't think that particularly blocks anything. It's just sort of, I like the idea.
Okay.
Yeah, one thing to add there is this would be also useful to have better support for like broadcasting the capabilities, as Tyson mentioned. So one area where I would want to leverage is like if container can support pulling in the action code directly from some attachment store. So instead of passing the whole code as a string, if it supports passing the URL and it can fetch it. So those kind of features can then later be advertised via this init protocol, and invoker can then change its behavior as per the capabilities published.
Okay. Yeah, good points. Shall we discuss the need for the synchronized block as well? As I said, I haven't really read it, but it's very helpful for me to understand your train of thought when it gets to actually review the thing. So
yeah, sure. I was just gonna try and do a quick little diagram here. So the first thing that we do to try and assign an invoker is we check concurrent slots, and I'm going to skip over some steps here, but if that fails, then we're going to say that we need a new container, right? So the checking, the creation of a new container goes through a process like we recheck concurrent slots, and then we attempt to create a container which allocates memory slots. And if that works, then we allocate concurrent slots. So it's these three blocks down here that need to be done in a synchronized fashion, because if we don't synchronize these, then in between here and in between these last two, then there'll be extra containers created if we have concurrent requests coming in that are all trying to do this workflow. Let me see if I can draw a line.
So that's basically implementing the behavior you want to, as a policy, you want to stall so that you don't overshoot. You'd rather stall some stuff for a second or two while a container is being created than potentially create extra containers?
Yes.
Okay.
So that's the other option is we say, and I don't necessarily have a huge opinion, although it's certainly nicer to, you know, so I guess another way to look at this is there's a couple of options. So one is to use the synchronization approach, and then there's a couple of options for synchronization approach. And then the non-synchronization approach is using, is basically just dealing with the fact that if you get a burst of 100 requests and your container supports a concurrency of 100, you will end up with probably closer to 100 containers as opposed to one container.
Yep, that makes sense.
So I am kind of leaning towards the pay up front the synchronization costs of creating that one container, and that first batch of 100 requests will have a penalty of some latency, but the next 100 is going to be kind of guaranteed to reuse that one container as opposed to 100 containers.
So I'm asking myself if a concurrent data structure can help. Like, for instance, a concurrent map has a, what is it, get or else update or get or create or something.
Yeah.
So it at least allows you to atomically check if something is already there and if not, create it. But I guess the hard bit is that the thing that's saved in there itself has a semaphore.
Yep.
Which we need to check.
Yeah. So like the concurrent slots and the memory slots can be modeled as a semaphore with an int or a long value, and that works pretty elegantly, I think. The problem is that we need to manipulate those semaphores in a coordinated fashion if we're going to kind of precisely model how many containers are created for a batch of 100 requests where the concurrency is 100 and the expectation is that you create one container for that batch instead of 100. So there is some use of trimap in order to track per action the concurrency semaphore, but the problem comes down to tracking two int values that fluctuate independently but have to be coordinated. And I tried a few variants. So one is just a plain synchronized block that obviously works. Another is having a third semaphore, which is basically is a lock on that combination of container and concurrency slots. I don't really know which approach is.
Okay, so what we need to do is the assumption is there's no container yet for let's start with that. So what we need to do is we need to get or else update on the map and then find a container that has memory, an invoker that has memory, and then create that concurrent semaphore with that. Is that correct?
Yes.
So I think on that path, we should be fine without a synchronize, because subsequent calls to the maps get or else update are not creating new containers.
Well,
because there's already one that got into there.
Well, but we're not tracking individual containers. We're only tracking the memory slots, and we only want to go down the path of tracking memory slots if the concurrency slots are not available.
Yeah, correct. So in the what I'm imagining is you ask the map, is there already an entry? If not, you want to allocate one entry anyway.
Before, you're talking about before the memory slots allocated.
Yes. So a request comes in, you check the map, is there a container for that thing flying around, which is a get operation? So, or is it?
Yeah. No. So the first thing we want to do is check for concurrent slots available for that.
Right, and for that
action.
You ask,
so that's using a map.
Yeah. So you can and that map can atomically tell you,
yes,
yes, there is one, or no, there is none. Do you want to create one? And that get or else update is an atomic operation.
No. So we can tell whether there's a semaphore created, but we can't tell atomically whether we can get anything from that.
Exactly. But the case that you mentioned earlier, where you said if 100 requests come in and there's no container, you could solve that by just doing get or else update.
Well, but there could be 100 requests coming in, and there is one container that has 100 requests in it already.
Yeah, but that's the second case.
Right.
That's the second case. I guess I'm trying to.
Yeah, so I went through many iterations of this, thinking the same thing, and was not able to actually produce something that worked.
Yeah, I absolutely know the dilemma of this. I know the dilemma of saying, oh no, I have two semaphores, I gotta need synchronization. Yeah. I guess, the only thing that I'm thinking about is if we can trim down the synchronization to not synchronize on the whole load balancer, but only synchronize on some object.
Yeah, so the synchronization that's there is only done on the concurrent slots that are tracking that specific action. I don't know if that's, and this is only done also for concurrent action. So where an action has concurrency limit greater than 1. So I tried to limit the exposure of the synchronization to only the semaphore that's tracking this.
Okay, I should have read the code. Okay, so the basically the assumption is that I checked concurrent slots, and if there are none for me right now, I synchronize on this object, create a new container, update that object with more slots, and then I'm good to go.
Yeah.
Okay. Yeah, that's absolutely sensible, and I even think, yeah, that's sensible. That should absolutely be fine. Don't see anything that could be quicker, and I don't see too much performance penalty on that, other than what Dave mentioned, where you say you want to be correct. You try harder to be correct than you try to be as fast as you can in this case, which I think is the right approach, because everything else is, at least from my experience with the OpenWhisk load balancer, everything else gets you into big trouble.
Yeah,
when you need to explain to somebody why some things happened this way and you can't.
Right.
So yeah, it makes sense to be correct first and then maybe adjust later if it turns out to be a problem. But that explanation absolutely makes sense to me for now.
Okay. I've got a little bit of ideas for refactoring things to be a little bit more clear and a little bit of cleanup to do. But if anybody has time and interest to look at this PR, I'm not sure what who folks might be interested in leveraging concurrent activations. Every once in a while, somebody I hear a mention of it, but I'm kind of interested to know if other people are planning to leverage this, and if you definitely if there are those people, if they want to take a look, that would be helpful. But yeah, I think the PR is close, and I think this is all. Thanks for the discussion. If people have comments, feel free to reach out on the dev list or in the PR.
Thanks a lot for your work and your explanation. It was pretty good. Thanks.
Yep.
Alrighty. Anybody else got something? Calling once, calling twice. Okay, then we are done with today's meeting, and it's my duty to find somebody who hosts in 2 weeks' time. Anybody who's eager to do it. It's really easy.
This is Dragos. I can do it. That would be in on 28th.
Sounds sensible.
26th.
Yeah, 26th.
26.
Okay. Yeah, I can do it.
All right. Thank you very much, Dragos. All righty. Giving us all back 10 minutes. Thank you all for your time.
Awesome. Thank you.
Have a good one.
Bye.
Bye.